Okay, so in order for us to use and play sound effects, of course, we need some sound effects first. And I actually looked up some free-to-use sound effects on OpenGameArt. Hold on. So we got these ping pong sound effects here. These are actually two sound effects, one when a ball hits a bat or a paddle, and one when it hits the board. And we can use these sound effects without having to download them by simply copying the URL of the sound effect here. For example, this one here, you can right-click, copy address. And now I'm going to go into the game settings object here. And say hit sound URL and paste that here. Like this. And also there's going to be a hit wall sound. And then there's going to be a score sound. Whoops. And I'm going to add the links of those sound effects to the description of this video. But you can find them on OpenGameArt also. Yeah, pretty straightforward. Let me just go ahead and copy the other links. Paste that here. And for the score sound, there's another one. This one right here. Win sound. Copy the address. And paste it here. Hit sound URL, hit wall sound URL, and score sound URL. Perfect. And now, let's go into the ball class. Now we need instances of the audio class. We can use that class to actually play audio files specified by a URL. So let's create some instances here and store them in fields. Let's say hit sound equals new audio. And to the constructor, we will pass the hit sound URL from the game settings. And then we need a hit wall sound. And pass the hit wall sound URL property from the game settings object to the constructor. Now we have some audio that we can play. And we want to actually create methods for that. Let's go here directly under the velocity property. And let's create a private method, play hit sound. And then here we're going to say this hit sound play. But also, once we played it, basically the audio instance keeps track of the playback time. So if we call play again for a second time, we wouldn't hear anything because the playback time basically is at the end of the sound effect. So we need to reset that. And we can do that by doing something like hit sound.current time equals 0, just to set back the playback time to the beginning, to the very beginning of the sound effect. Let's copy this, paste it, and rename this play hit wall sound. And do the same thing here with the hit wall sound field. Now, whenever the ball hits a wall here, we're going to say this play hit wall sound. Do the same here. And whenever it collides with a paddle, we're going to say this Playhead Sound. Call the Playhead Sound method. Same thing for colliding with the right pedal. And yeah, that's it. And also in the chord class here, we're going to need to add a new field. So let's go into the constructor of the chord class, and let's go somewhere here. This score sound equals new audio, and pass the score sound URL property of the game settings object. I think it was score sound URL, right? Yes, that's correct. And now in the method named score point, we're going to play that sound. So this score sound current time equals 0. This score sound play. Oops. Save. Run. Start the game, and now we should hear some sound effects. Perfect. All right, so the only thing really that's left for us to do is to implement the AI for the computer opponent. And let's just dive right in. Let's go somewhere down here above the scoreboard class. Let's add a new class. Let's call it CPU pedal controller. And we're going to add a constructor that takes an instance of pedal and also the ball. And we're just going to initialize two fields with these argument values so that we can use, well, of course we need the pedal that we want to actually control, and we need the ball as a point of reference. Because the strategy that we're going to go here is basically something like this. So this is the paddle and this is the ball. And the goal of our AI is to always try to correctly predict which direction it needs to move in order to move towards the ball. So here we have like a vertical delta between the pedal and the ball. And of course we have a horizontal delta here, which is the distance. The yellow line here is the horizontal distance to the ball. And basically, the closer the ball is to the pedal, the higher the chance that the pedal moves in the right direction. Because if the ball is really close, obviously it's easy for the computer, for the AI to tell where it needs to go. So we're going to have like a minimum prediction distance and a maximum prediction distance. And yeah, the closer the ball, the easier it is for the pedal to predict the right movement that it needs to do. And we have a min distance because basically if the ball reaches a point where it's like 20 pixels away from the pedal, we're going to treat that as if the distance was 0, basically. So if the ball is really close, then yeah, it's basically as if it was directly in front of the pedal. So it makes it easy for the AI to predict the correct movement. So this is basically the formula that we're going to use. So distance here is the distance to the ball, the horizontal distance. We always subtract the minimum prediction distance, divide that by the maximum prediction distance, and yeah, then we also factor in a margin of error. What does that mean? Basically what we want to do is the faster the ball gets, the higher this value gets. So it gets harder for the AI to correctly predict the movement. So when it's really slow, the error margin value will be really low. So only a small value will be subtracted here. But if it's really fast, then we're going to subtract a large amount. And yeah, we basically base the error margin on the current speed of the ball. So let's take a look at the code and how we can achieve that. So the first thing I want to do is create 3 static properties here. Prediction distance max, which is the maximum prediction distance, which is 400. Then the prediction distance min, which is 20 pixels. Whoops. And also the error margin, the max value of the error margin, that will be 0.5. Now, let's create a method to calculate the actual error margin to apply. It's going to be private, and I'm going to name it calculate error margin. And what we're going to return is the value of error margin max scaled by the normalized speed property of the ball. Remember, we implemented this property in the ball class to basically, well, if the ball was moving at its minimum speed, normalized speed would return 0. If the ball is at its maximum speed, then normalized speed returns 1. So if it's at maximum speed, that means error margin max will be multiplied by 1. That means we factor in the entire error margin, the full amount, the full 0.5. And if it's 0, if it's minimum speed, then we don't factor in the error margin at all because it's multiplied by 0. Now, let's add another method here, getBallDistance, which calculates the distance, the horizontal distance to the ball, which is also simple. There, if we just subtract the ball position, the x position of the ball from the x position of the pedal, we get the distance. But since the distance cannot really be negative, we're going to use the abs method here to get the absolute value, meaning that it's always going to be positive. So even if this was to return -10, then the abs would convert it to 10, the abs method. Okay, and now we're going to add another private method named getBallPredictionChance. Get, this is supposed to be get, not guessed. getBallPredictionChance. And this is actually our formula here. So let's see. First, let's calculate the distance and subtract the minimum prediction distance from that. Gonna make this a little smaller here so that it fits. Something's wrong here. No, that should be okay. Oh, whoops. This is supposed to be an equal sign, of course. There. And then let's calculate the error margin using the method that we just created. Calculate, just copy it here. There we go. And then we're going to return 1 minus distance divided by the maximum prediction distance minus the error margin. And that should be fine. So now basically the faster the ball gets, the higher this error margin value will get, meaning that the prediction chance value that is returned will be lowered. And the lower this value is, the lower the chance that the AI correctly predicts the right movement. Now let's implement an update method here. That's going to be public. It's going to take in a parameter named delta time. And first of all, let's generate a random number. I'm going to call the variable RNG. Use the math random method here. And then I'm going to call the get ball, let me just copy it. The get ball prediction chance method and store the returned value in a variable named predict chance. And then let's calculate the vertical delta. Well, actually, it's not, we don't really calculate the delta. We just want to know whether the ball is below the pedal or above the pedal. But I'm going to call the variable, the local variable, ball delta y. And what we're going to do is, something like this. So we subtract the ball's y position from the pedal's y position, but we do add, but then we add the half of the height of the pedal to basically get the vertical distance between the ball and the pedal. And then we get the sign of that value so that it's restricted to -1, 1, or 0. Now we can check if the random number that we generated is less than or equal to the predict chance value that we calculated. And if that condition is true, that means the AI correctly predicted the movement that it needs to do. And so it needs to act accordingly. So now let's check if the delta is greater than 0. That means the ball is above the pedal. So the pedal needs to move up and pass the delta time here to the move up method. Otherwise, the pedal needs to move down. Now, if it doesn't correctly predict the movement, what we're going to do is we also include a slight chance that the pedal goes in the opposite direction, just to add some variety so that it doesn't stand still always. Sometimes it even makes a mistake and just moves in the wrong direction. So we're going to generate another random value, and if that value is lower than, let's say, 0.2, so a 20% chance, then we're going to copy this and simply swap these two method calls. There we go. And I think that's it. Let's see if this works out. Obviously, we need to instantiate this somewhere. And we're going to do that here in the court class. Up here. We're going to go in the constructor. And here. After instantiating the ball, we're going to say this. CPU controller equals new CPU pedal controller, and then we need to pass the pedal, the right pedal, and the ball. I think the order is correct. And now that we have this instance of CPU controller, we need to also update it. And we're going to do that in the update method of the court class here. After the player controller gets updated, we also want to update the CPU controller. Delta time. There we go. I'm going to go ahead and save that. Run. Quick start game. Make this a little bigger so we can actually see everything. Click start match, and now it should move. Yes, it does. Oh, I accidentally refreshed. Let me start again. And as you can see, the closer the ball gets, the more accurate the movement of the CPU pedal becomes. See? But it's going to make mistakes. It's not always going to be correctly predicting the movement. So at some point, you will be able to score a point. Come on, come on. Yeah, almost. I'm gonna get you. There we go. We scored a point. And now the ball is slow again because it gets reset once a new round is started. And yeah, I think that's basically it. I'm going to clear the console, start it again maybe. Let's see if there are any errors. But that doesn't seem to be the case. So generally speaking, we're done. There's just a few more adjustments that I want to make. Slight enhancements. First of all, I want to be able to mute the sound. Because yeah, maybe you want to play in silence, maybe you don't want that, maybe you find the sounds annoying, I don't know. So let's do that next. Alright, so what I want to do now is implement the possibility to mute the sound so that you don't always have to play with those sound effects going on. And we're going to implement that in a very simple way. I'm going to go ahead and go all the way up here. Let's say, it doesn't really matter here. I'm going to add a global variable that is initialized to the value false. So it's just going to be a flag, a boolean, that stores whether or not we muted the sound. And now I want to add a button that we can press to toggle the value of this. There. And let's go ahead and add a new button here of class button. The ID will be button or btn toggle sound. And when we click it, we want to call a JavaScript function named toggle sound. And we're going to create that function in a second. And as the label, we want the button to say sound off. And now let's implement this function by going somewhere here. Let's go all the way down here and say function, function toggle sound. And what it's going to do is it's going to negate or invert the value of isMuted, of this isMuted global variable. But that means that we also have to change the text on the button, because once we toggle the sound off, obviously the button then needs to say sound on. So let's do that. Let's say document get element by ID, pass the ID here, which is btn toggle sound, and then we can set the inner HTML to a new text, and the text depends on whether or not it's muted. So if it is muted, then the text should say sound on, otherwise the text should say sound off. Oh, this is supposed to be a question mark, of course. Ternary operator. So we're going to set the inner HTML depending on the current value of isMuted. If it is true, if it is muted, then the text should be sound on, otherwise the text should be sound off. And yeah, this should do the trick. Oh, whoops. HTML needs to be spelled in all caps. I always mess that up. Save. Run. And now when we click this button, we actually toggle the text and also the value of this isMuted global variable. Okay, let me save again. And now let's actually make the button actually do something. So let's go into the ball class. Where is it? Here, ball. And then go into the Playhead Sound method. And here, let's add like a guard clause. If isMuted, we don't want to do anything. Same here. Yep. So if the sound is muted, don't play any sound, don't do anything. Same in the chord class when we score a point. Here, only play the sound if not isMuted. Then we want to do this. And that should be it. Save. Run. Start game. Start match. Now the sound should be playing. Yes, it is. Once I click here, it's no longer playing. And I can switch it back on. Click again, switch it off. And it's not playing any sounds. Perfect. There we go. And now let's make some slight design adjustments here. Let's, for the button class here, let's say it has a margin at the bottom of 20 pixels so that it's not directly above the game screen here. Run. And now there's a little margin here. And what else? Let's say the start button by default is display mode block. That makes it, well, you can design this whatever way you want. I'm going to go with this. Oh, one more thing. Let's only show the toggle sound button once the game is actually started. I think that would be a good idea. let's say button toggle sound. Let's by default set the display mode to none so that it's invisible. Run. And once we click start game, here, let's change the style, the display property, to something like inline block or block, whatever you want, so that it becomes visible. And that should do the trick. And let's also maybe make the background entirely, well, maybe not entirely black, something like dark gray. Save. Yeah, that looks great. So now when I click start game, the sound toggle button appears. I can start the game and play our game. Perfect. So I think we're done. I think we've actually covered everything. So, great. So thank you guys so very much for watching. I hope you enjoyed this video series and I hope you learned something. And as always, all of the resources and the source code can be found in the description. I'll leave a link to the actual jsfiddle project. So leave a like if you enjoyed this series, and I hope to see you guys in the next video. Bye-bye.